Hello students, today I have come up with the last part of halogens for class 12. Okay, today I'll continue with the halogens and complete the interhalogen compounds, which is an important part of your syllabus. So, let's start. Interhalogen compounds. Now, what are interhalogen compounds? Interhalogen compounds are basically those compounds which are comprised of two or more different halogen atoms. For example, IF5. IF5 consists of one iodine atom and 5 fluorine atoms. Here the iodine atom is the central atom and the fluorine atoms are the constituents. Okay, these are known as interhalogen compounds. Interhalogen compounds are of two types. Neutral and charged. Among the neutral halogen compounds, examples are chlorine trifluoride, iodine pentafluoride, bromine trifluoride, iodine heptafluoride. There are many examples of neutral interhalogen compounds. Among charged, they are of two types, positively charged and negatively charged. Among negatively charged, the examples can be I3 minus, ICl4 minus. Among positively charged, the example can be ICl2 plus, ICl4 plus. Okay, there are many other negatively and positively charged interhalogen compounds. Okay, so these are basically about the classification of the interhalogen compounds. Okay, there are four types of interhalogen compounds. Okay, first let me give you the general formula of interhalogen compounds. General formula is X dash N, where X is a particular halogen atom and X dash is another different halogen atom. And the value of N can be 1, 3, 5 or 7. Okay, now let's come to the types. I can write like this. X dash where N is 1, X dash 3 where N is 3, X dash 5 where N is 5, X dash 7 where N is 7. Now this type of linear compounds, example can be CLF. These type of compounds, the shape and or geometry of the compound is linear. For XX3, the geometry of this compound is, or the shape is T-shaped. For XX-5, geometry is square pyramidal. For X7, it is pentagonal bipyramidal. Okay, these are the 4 different types of interhalogen compounds. Okay, now let us come to the next part. The next part, which is, you can say, the most important part of this chapter, the shapes of certain interhalogen compounds. That is the structure of the compounds. The first example I am showing is ClF3, where Cl is the central atom. There are 3 fluoride atoms and 2 lone pairs. Okay, now remember one thing, that these 3 positions are equatorial positions and these 2 positions are axial positions. Always the lone pairs are present in the equatorial position. Okay? Now, this totally, the actual geometry of this, now you can understand this is sp3 hybridized. The ideal structure will be trigonal bipyramidal, but due to the presence of the lone pairs, there will be lone pair repulsion, due to which these axial bonds will bend a bit. This will bend a bit. These 2 axial fluorine atoms will bend a bit towards this fluorine atom, and the actual structure will be T-shaped. Okay. The next compound is IF5. I is the central atom. Okay, see, since this lone pair is below the plane, so we can show like this, that this is the plane and this lone pair is below the plane. So I have not kept this circular part above it, or I could have written like this. Okay, thus you can see the ideal structure is octahedral, but due to the presence of this lone pair, the actual structure will be square pyramid. And the hybridization is sp3d2. The next compound is IF7. This is the structure of IF7. The structure you can see is pentagonal, bipyramidal, and the hybridization is sp3d3. Okay, this is of IF7. The next structure can be of I3 minus. One of the eyes will be the central atom. There will be 3 lone pairs. Okay, and the total will have a negative charge. Okay, this is interhalogen compounds I3 minus. This is the negatively charged molecule whose structure can be written like this. Now I'll come to another this type of negatively charged molecule. Oh, okay. Before coming to the next molecule, let me tell that there are the actual structure of I3 minus should be TBP and hybridization is sp3d. But due to the presence of 3 lone pairs in the equatorial position, the ideal was TBP, but the actual structure is linear. Okay. Now let's come to the last molecule, ICl4 minus. See, in ICl4 minus, you can see that the ideal structure will be octahedral with sp3d2 hybridization. But due to the presence of 2 lone pairs in the 2 axial positions, the actual structure differs from the ideal structure, and the actual structure is square planar. Okay. I could have just given the types of, I could have just shown you the different types of XX, like the structure of XX3 or the structure of XX-5. I could have generalized the structures, but I didn't do that to show you with different examples that how the structure appears in the particular molecules. Okay. These are more or less about the interhalogen compounds, and with this I am ending the halogens and also your first unit test syllabus till P block elements. In my next video, I'll just tell you about the denticity of the coordination compounds, and with that your syllabus for your first unit test will be complete. Okay, thank you.